Hi guys, we're Team Never Lose Passion. The system we built is called HiWiki, a question generation and answering system based on Wikipedia articles. And here's the brief introduction to our system. So let's firstly talk about data pre-processing. The articles from Wikipedia are usually long and full of long sentences. To make it easier for our system to understand the text, we need to break them into simple sentences. When an article comes in, we first do sentence tokenization. Then we try to get simple sentence boundary. We use dependency parsing to get the sentence structure and use hints from keywords and punctuations. For example, in this sentence, the tag WRB indicates that the last part is a subordinate clause and can be removed. The resulting sentence will be, in the late August 1961, Barack moved to Seattle. After data preprocessing, we have a list of simple sentences. For each simple sentence, we generate both binary questions and WH questions with the following pipeline. First, we identify name entities and special terms in the sentence as answer phrases and generate the corresponding question phrases. And then we decompose the head verb. We identify the head verb of the sentence and decompose it into its corresponding auxiliary word and the lemma of the verb. Next, we invert the subject and the auxiliary and insert question phrases at the beginning of the sentence. Finally, we post-process the questions to make it grammatically correct. Here's an example. We input a sentence in late August 1961, Barack moved to Seattle. We generate question phrases from answer phrases. In this sentence, we generate when from late August 1961, who from Barack, and where from Seattle. We add the auxiliary did before the head verb move and swap the subject Barack and the auxiliary did. Then remove the answer phrases and insert the corresponding question phrases. Note that for who questions, we only need to replace the person with who, and for binary questions, we don't need to insert any word. Furthermore, we capitalize the first letter and add a question mark in the end. Last but not least, to generate binary question of which the answer is no, we substitute another name for the subject of the binary question of which the answer is yes. And then let's talk about how we evaluate and select our questions. So when we are selecting our questions, we take three things into account: the difficulty level of each question, the length of question, and the diversity of our question set. To get the difficulty of each question, we trained a random forest classifier based on the question answering dataset generated by students who took NLP course at CMU and University of Pittsburgh in spring 2008, 2009, and 2010. The difficulty of the questions are pre-labeled by the question writer. So after pre-processing and feature engineering, we trained the random forest classifier. The features we extracted contains the question type, whether it's a yes or no question, what question, where question, etc. Its tense, whether it's past, present, or future. We did one hot coding for these two features. We also have the mean unigram language model log probabilities in each question, the number of tokens in each question, the count of noun phrases, and prepositional phrases in each question. We split the data set into train and test. The test accuracy reached 88.7%, and here are two examples of how our classifiers work. The performance looks pretty good. Here's our grading rubric. When the length of a question is beyond a threshold, it gets some penalty. To diversify our question set, we also give the weights to different question types. For the question answer system, our system consists of three parts: question pool comparison, answer comparison, and answer processing. As mentioned in previous slides, we generated questions from each short sentence. In the meantime, we also store every question's corresponding short sentence, which is a valid answer to our question. As parsing can be computationally expensive, we decide to use the resource we have generated in question generation first and see if we can get a good answer. When we get a user query, we feed the query into our question pool and compare the distance between user query and every question we generated. We use Levenshtein distance as a comparison metrics in this part, which shows top 3 questions that has a Levenshtein distance lower than a certain threshold. If there doesn't exist any, we will do the NER based question answering. After we got the 3 questions, we retrieved the 3 corresponding short sentences that our questions generated from the computed and compute the similarity between 3 short texts and user query. Here, what we want to do is basically trying to find whether the sentence has the information we need, and we use Jcard distance in this part. If there is no sentence that has the similarity larger than 0.35, we will go back to NER-based question answering. Otherwise, the sentence with largest frequency is the candidate answer. Here's a brief illustration of our previous flowchart. The user query is where did Barrack move to in August 1961. We search our database and got the top 3 questions that are the nearest to the query. Then 3 short sentences are retrieved and we computed the similarity between these 3 sentences and the query, and we got the second sentence as our answer. Yeah, and that's all. Thank you for watching.